alaikum wa rahmatullahi wa barakatuh, dear students. Hope you are doing great. In this session, we will start with a Kangaroo mathematics questions for 2022. Let's start with question number 1. Question number 1 here. We have those 6 points from 1 to 2. From 1 to 6, 6 points are numbered as shown. Watian draws 2 triangles, one by joining the even numbers and one by joining the odd number points. So even and odd. And then she colored them into red and green. So one is red and one or the other one colored by the green color. Now, which of the 5 options here from A to E was the picture that Watian did? Here, let's see. We said 1 for the odd number, so 1, 3, 5. And the other one was 2, 4, and 6. Now, which one is which one of the options is the picture that Watian drew? Here, let's see. I can see that this is straight line and there's a straight line here, so I may have that right angle, and the only shape that has this situation would be not this, not this, not this, not that, and E is the right answer for this question. It was so easy. Now, moving to the next question. Question 2 here. Iman rode around 5 bios, as shown. Which bios did Iman row around in an anti-clockwise direction? So, let's move with the arrow, the starting point, and see which one she rode anti-clockwise. So starting by this is anti-clockwise. Then she moved, this is clockwise, anti-clockwise, clockwise, clockwise, then she moved back here. So I have the option 1 and 3. Where is 1 and 3? It is also option E, so E is the right answer. Moving to the next question. Question number 3. Question 3 here. Laser beams reflect in mirrors in the way shown in the picture 1. So, this side, then this side, then this direction. Now, at which letter will this laser beam end in picture 2? So let's move on picture 2 as they showed us on the picture 1 here. So they started here, so I will move here, then move to this direction, this, moving here, then up to this side, to this side, to this side of the mirror, again this side, this side, this side, this side, and moving out. So this beam will move until it reached B. So B is the right answer. Point B will be the last point that the beam can move at. Moving to question 3 or question 4. Question 4. Here we can see some symbols and we need to know what's the meaning of those. Here, Cistercian numerals were used in the early 13th century. Any integer from 1 till 99 can be represented by a single glyph formed by combining 2 of the glyphs here. So those are glyphs. Now, the glyph for 24 looks like this. Now let's see 24. So this is 20 and this is 4. How can they find or bring this combination, imagine they put them above each other. So the vertical line, above the vertical line, so I have this and that. This is 24. Similar to that, let's see 81. So 80 here and 1 here. Put them above each other. So you will have this, this, and that here, similar to this symbol or this glyph. And 93 again looks like this. They want us to find the glyph for 45. 45. So this is 40. So I have 40 like this here. And what about 5? 5 is another vertical line with this triangle here beside. So I need to look for this shape. This is not correct, of course. Of course, this is mirror image for my answer, and this one would be the right answer. D is the right answer. Question 5. Marbles are sold in packages of 5, 10, or 25. Tamim buys exactly 95 marbles. What's the minimum number of packages he could buy? Minimum number means that I need to look for the huge number here so I can minimize the number of packages that Tamim bought. So we have 25, then 25, then 25. That makes 75. How much left? He needs to buy 2 of 10 packages. Those 2, that makes 95. So they said exactly 95. So 1, 2, 3, 4, and 5. So 5 is the minimum number of packages that Tamim bought to have 95 or exactly 95 marbles. Moving to the next question. Question 6 here. ABCD is a square with side length 10 centimeters. What is the area of the shaded part? Now let's see the shaded part. It's here, here, and those small areas. Now, since this is a square, so we have symmetry on this side, and this side, and this side, and this side. So what we can do, we can easily move those 2 sides here. So I have exactly this whole triangle shaded. And I can do the same here. I will move those up to here, so I have this triangle also fully shaded. Now, what are those 2 triangles compared to the square? This is 1/4 and this is 1/4 out of the square. That means those represent half of the area of that square. So easily we can find the area, which is 10 times 10 equals 100, and this 100 needs to be divided by how much? By 2, because we said this is half of the area of the square divided by 2, which is 50, and the measuring unit is square centimeters, so C would be the right answer, 50 squared centimeters. Now, let's move to the next question, which is question 7. Question 7. Question 7. Question 7 is the following. In this garage here, vehicles can only move forward or backward, but they cannot turn. So what is the smallest number of those vehicles that have to move for the black car to be able to exit the garage? So our target is this black car, and we need others to move in order to leave the space for this black car to move out of the garage. Now let's think about the minimum number of items that we can move them in order to let the black car move out. Let's see. Now, based on squares, the one that is blocked the exit here, this bus, and we need to know how many squares I have to move it. If it moves backward, I will not have any benefit, because if it moved to the back, I saved only 1 square, so this part will be here. So it can't. 1, 2. I need to move it 2 squares. 1, 2, 1, 2. If it moves here, I can have this black car to be free to move out. So how can this be made? I need to free this space here. So I need to make this car or this part move 1 here, 1. So the length of this is 1, 2, and 3. So 1, 2, and 3. Now I need to move this car again, follow to this bus. So this will move here, this one will move here, and this one will move here. This will move here, and now the space is free for the black car to move. So 1, 2, 3, 4. 4 is the minimum number that we can have in order to free the black car to move out of this garage. And moving to question 8. Question 8 now. Jalila has 1 long string of spaghetti here. This one, the long one. She needs to make smaller. Every time she breaks 1 piece of spaghetti, it becomes 3 pieces, as shown in the picture. So this long one, she tried to cut into pieces. It turned into 3 pieces. And that means every time if she wants to cut this into pieces, again, it will be divided into 3 pieces, and so forth. Now, which of the following numbers of pieces could she not get? Let's see the options. 13, 17, 20, 23, and 25. By having a quick look here, I can see odd, odd, even, odd, odd. This is my first impression about numbers. Now let's see the number of pieces that she may have. So first of all, she had 1. Then she had 3. If she cut this into pieces, this will be 3 and 1 and 1. So 3 plus 1 plus 1, that makes 5. But if 3, this one will be another 3. 3, 3 plus 6. 3 plus 3 equals 6. Plus 1 equals 7. If she cut all of those pieces, 3 plus 3 plus 3, that makes 9. Let's see the pattern. 1, 3, 5, 7, 9. So the rule of this pattern is adding 2. So, and odd numbers. Each time 2 pieces will be added, and the number will be 11, 13, and so forth. So I'm adding 2, and I'm having as a result odd numbers. So by looking to the options here, the only even number is C, which is 20, and this is the only number that it is impossible to be resulted while Jalila cutting her spaghetti. Moving to question 9. Question 9. Badr rearranges the 7 pieces here, 1, 2, 3, 4, 5, 6, and 7, to get the smallest possible 12-digit number. What is the last 3 digits of this number? Last 3 digit means the first period, which is ones, tens, and hundreds. Those are the period here, or the last 3 digits. Now we need to know if he arranged or rearranged those, what would be the last 3 digits. To have the smallest possible number. Smallest number means I may have or I must have the biggest number or numbers at the beginning of my number or at the end of my number, starting from right to left. So, what are the biggest numbers here? I have this and I have this. Others can be arranged later. So, I may have 9, 9, and 6, which is, out of all those 5 options, it is option A for this question. And question 10. Question 10, which of the following fractions of a whole turn should the Ferris wheel turn to bring the white pod to the top? So this is the wheel, and those are the pods here. We need to see what is the fraction that this wheel turn in order to have the white pod on the top. So first of all, they are asking us for a fraction. So let's see what is the total number here of the whole. So starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I have out of 12. But be careful, I have to make sure what is the number here to avoid any conflict if the options had any of the equivalent fractions. So this might be my answer, but I have to double check. Now, move the wheel in order to make the white on the top here. Move it. You will move it one fraction, either from this side or from the other side. They didn't mention to which side or to which direction the wheel is turning, clockwise or anti-clockwise. So I had the same result from here or from there, and I will move only one fraction, so 1 over 12, and D is the right answer for this question. By this, we will stop for this part of Kangaroo questions for 2022. See you in the next session, inshallah. Have a great day and bye-bye.